Alrighty, so we'll be soldering this board for the Breakout, and some of the techniques here, you'll be able to use that for when you're soldering your motor controller. So this is the set of pins that comes with it. Now you can choose which side you want to have up. There's both this one and this one. This one just has the pin numbers, GPIO pin numbers, where this one also has information about what the pins do, and also it's a different numbering convention between the two, where this one is like the GPIO number, where this one is the pin number. Now, I'd recommend using this just pin number, as it tells you the actual number for the one that's labeled like here's CE0. Once that focus, CE0 that would have a corresponding GPIO number. And for this setup, for the code for the robot, we use some of these pins that are labeled differently. Like for instance, the SCL and SDA, we're using that for our I2C1, and then for our secondary I2C bus, we have to use one of the other pins that's labeled as something different. So it can be easier just to reference this and just see that, well, it's the GPIO 24. So we'll have this side up. Now, I'll get this. Let me set the iron down here. So we will first be putting on these terminal blocks, so that way you'll be able to have access to them. It's kind of tight either way. Or let me see here. No, we need to do this first. So we'll do this, and in the end it'll look something like this. So in order to have the easiest soldering job, we'll solder these first, and then we'll come around and we'll just go along the outside and solder those. So now we can just get that lined up. Let me zoom in even further. There we go. So now we got up close. This is just some relatively coarse solder. This is just what I have on hand up here. Finer solder is easier to work with, and we'll see how well this works. I might end up running downstairs and grabbing some finer solder to make this go easier. But for just this quick video, this will do the trick. So now what I like to do when working with these big pin blocks here is I'll start on one corner and just figure out what end of the iron is ready to take solder, put a bit on, hold the iron onto both the pad and the pin, then come in from the other side with the solder. So now we'll let that set, and now we have that corner tacked into place. Come around on the other side and tack the other corner. So if you have more experience welding than soldering, just think about this like tacking your parts while you're welding. So now that we got that tacked, that's all set and not going anywhere. So then now we can just come across and quickly hit all these pins. So I like to alternate the pins that I'm doing, like skip one and put solder onto it, just so that way you're not soaking so much heat into the part. Given that this terminal block is all made out of plastic, there's a risk of starting to melt some of those pins in there and damaging something. It's unlikely, but there's still a risk there. So just being careful with it and making sure you're not dumping a ton of heat in is always useful. So doing that here again. Now I rotate it onto the other side. Just quick hopping along. And now I'm just hopping back and filling in some of those. I'm doing them on the same side here, but just to try to speed up the process. Now, if you're soldering for the first time, I recommend taking it easy, starting on something that you're willing to mess up. So you can get proto board or perf board that's just a piece of fiberglass with all the holes like this, that's at the right spacing for just generic pins. And with it, you can just kind of go to town with that and solder, get some solder practice on there. If you're new to it, not the most confident, I recommend giving that a go before you jump into a soldering project like this. You don't need to. If you have experience doing other projects like this, you'll be able to pick it up pretty quickly. But it is something nice to do just for that confidence building. Now we're looking at that and inspecting it. That looks pretty good. A few of them here that could probably use a little bit more, like this one right there could probably use a little bit more. So I'll add a bit more solder there. Now, tip's gotten a little bit dirty and just covered in old solder and burnt rosin. So using this, I'll just rub it around in there, and this is just like copper wool, so then that cleans off the tip really nice. And to make sure that you're able to keep the tip clean, you'll want to do this every time when you're done doing a solder job like this. That'll make sure that this stays good and you won't have to go at it with some real steel wool or some other aggressive scrubbing agent to clean off the tip to be able to keep it working well. Set that down over here. Now we'll flip it over. I'll just inspect this myself. Yeah, so this is looking good. So now on these screw terminals, I'll show you how this goes. So we have terminal blocks here. Ooh, screw, that's too big. So on here, this is the side that you screw down, and right now it's all the way closed. So you'll put your wire into, oh boy, that's having a hard time focusing. You'll put your wire into the top part and then you'll screw it up. So then this is just the back of it, which you could additionally put wire into if you needed an extra one. So we'll put this guy, we'll want it to be in there like that. So another cool trick about this, these don't have it. On these, on this block, you'll see on the side how there are those two, a raised part and a lowered part. Those fit together, and that's how you get these to be right next to each other. On these though, you just have to put them in and make sure they're lined up. So now I'm holding these in with my fingers and just flipping it over onto the table and making sure that everything is lined up nicely. So now that everything is lined up nicely, do the same thing as I did before, but now remembering that there's two of them on here, so I'll just tack this side, spin it around again, tack this side. Just make sure that we got everything ready to be soldered. If you're working with leaded solder, you'll want to make sure that you wash your hands afterwards before, grabbing a bite to eat or putting your hand in your mouth. just so that you don't get that exposure to the lead. Really, the only way that you're exposed to lead with lead solder is actual consumption of it. This steam you see coming off of there, that's the rosin. So that's what's in here and prevents oxidation of the metal while you're doing the soldering. It's not good to breathe it in, but that's not full of lead or anything like that. So definitely wouldn't recommend sitting right over it to not having good ventilation in the space that you're working in, but it's not something you have to worry about for lead poisoning. And after this project, I'll make sure to wash my hands before moving on to the next part. Again, not something that you need to be super worried about or scared about, but it's just a good practice to be in. So now we have this part done, we can start looking at the other mechanical components, or electrical components, and getting those set. Let's zoom out here. There we are. So we have this all soldered up. We have our extension block here, so I'll show you how that can go on. That we will just align with that and then push it in. Make sure you don't put a hole in your fingers while you're doing it. So we got that. Now we can push this guy on, and then you'll see in there, there's a hoofda. I need that to focus. It says USB there, so that you'll want to have pointing in this direction. So pointing towards the USB plugs, just like that. And then that way your numbering will match. So most of the pictures that you'll see out there for the GPIO pins are set up like this. This does get it a little bit tall compared to some of the other options out there, but we account for that in the height of the this lid here that goes over it. So there's the Raspberry Pi all set. Now let's take a look at wiring up our encoders. So for these encoders, we'll have them mounted on the side of the robot, like right like this. Let me zoom you guys out. Right like this. So those will be mounted on here, right like that. And we'll have the Raspberry Pi sitting right there. So we'll need wires that run from here all the way up and around into here. I recommend when you're working with this just 24 gauge wire, just make it longer than you need to, and then when you're doing the final run to here, then you can nip it shorter if you want to, or just do a little service loop, maybe have a little bit of extra wire in here. We aren't dealing with really high voltage and high current stuff, so the risk of electronic noise and things like that is low. It's still a risk, and you want to make sure that you have your high voltage and low voltage running perpendicular to each other to prevent that magnetic interference. But I recommend, again, just make your wires longer than they need to be. When you get to the end of it, cut them if you want to, or just leave it there with a service loop. That's the best way to do it. So we'll get started on soldering on this guy. We'll get those out of the way here, so then we can just focus on the AS5600. I'll zoom you guys back in. So now for this guy, we're dealing with a part that has labels on it on the side that we're going to have facing away from us. So I've already put the little bit of solder on here just to tin the connection. A phrase that you'll hear me mention is tinning. So tinning is when you take a bare wire and you add some solder onto it to make it hardened like this. So that's a tinned wire, and this is a tinned connector. So for that, given that we have the letters on this side and we're not able to see it on this side, you can see this square right there that corresponds to the DIR pin, and the VCC is also square. Can't really tell now with the solder on it. You can tell a little bit. But we'll just have to make note of that when we're putting the soldering the wires on. So now tools for this. I recommend picking up a one of these higher gauge wire strippers. This one goes up to 26 and down only to 16. This is really nice for working with this scale of electronics, because on wires like this 24 gauge, you can really get in there. I like to use the 22 gauge stripper for it, just so I make sure I'm not cutting any wires. You don't have many wires to work with here. So it's really convenient for that. So you can just cut your bit of wire off there. We'll start with our red and black, our power connectors, our power connections. Strip about that much off of it. And then we'll tin this connector and get it attached. Another tool I'll point out is just the nippers. These nippers, flush cuts, are really great for trimming wires. Eventually, when we get to adding zip ties, they're nice for being able to cut the zip ties flush so that you don't cut your finger when you're working with it. All right, we'll zoom all the way in here to what we're working with. So now I've cut our wire, and now let's start tinning them. So you can work with like helping hands like this, or a vise or something like that. I've gotten in the habit of just working with my fingers. If you're new to this again, I strongly recommend putting things into a vise, doing it like that. But if you either A, don't have a vise, or B, you are confident enough that it's not confident enough in your soldering ability, you can get by quite easily without a vise or a fancy setup like that. So the best way is just to get your wire propped up a little bit like this. I'll slide you guys a little bit closer here just so we have a better field of view. Ooh, I want to make sure the phone doesn't drop though. All right, I think that'll be a good view for you guys. So now that we have that propped up there, we'll just put a little bit of solder on the tip, get that next to the wire, and we're just trying to heat up the wire enough for it to take on the solder. So see that little bit of bubble in there? That means that we should be good. So now I'll show the camera here, and note that the wire does heat up. This I like to use the silicone wire. It's just a lot more flexible and easy to work with. So that's what you're looking at when you're done. So if you're putting a lot of heat into it to try to get it to take up the solder, there's a chance that you might, your fingers might get a little bit warm. Now I've already got a puddle on my, the tip there, so now we'll just come in like this, that solder hanging, and those bubbles are good because that means that the rosin is doing its job. Now I've got a puddle of solder there, but I'm just gonna wipe that off into here to make sure that the tip stays clean and we don't burn that solder. So there we go. Now that we've got that, let's add these wires onto here. Now we remember that we need that square. That's our positive VCC. So, and I'm gonna have the wires aligned like this. So we'll first have our power, and we'll have a little bit longer line for our SCL and SDA for the signal. So now for this, you can just set it down like that. And it helps to have a finger on the part that you're doing. So you can get to be a little bit tight to make this work, but I just go like that, bring in the soldering iron, try to melt both the solder on the wire and on the part. And then now we've got an okay connection there. I'm gonna reheat it and move the wire over a little bit. There we go. Now we'll have a good connection. That's what you're looking for on these. So there we go. So there's our positive and negative. Now let's do the SDL and SCA. So I have not found an official color code for dealing with I2C on a system like this for what color the D and the C, the SCL and SDA in a CAN system and other 2-pin data systems. There are distinct color codes for what you should use on each one. I typically do D is green and C is yellow. That's how I've done it, and that's how I'll be doing it here for our this robot. So with C being yellow, making a note that C is on the side of the square. We'll put the yellow on that guy, and then we'll do the green next. So again, one thing actually to show you here is we've got a little bit of wire sticking out there. You can kind of see that glint right there. So if we have that, I'll come in with a flush cut, get that closer to you, and I'll just try to peel that up and just nip it off just so that we don't have any issues with something potentially getting bridged. There we go. And maybe not. Yeah, we got it. So that's why I like to keep these flush cuts around. I usually just cut wire with the wire stripper most of the time, but it's nice to have them on hand to be able to do little jobs like that. So now, again, just like we did for the positive and negative, bring this guy in. Make sure we're melting the solder underneath too. So you want to hold that heat on long enough to melt the solder down there. There we go. So now that's one of these. I'll clean the tip off now that I'm done and gonna leave the iron sit for a minute. And I will zoom us out. There we go. So we have got this guy done, and now we'll approximate the length of wire that we need running up to the part here. So we know that this sits about like this right here. We'll want wire to come up. Maybe you need it to come around. We'll go something like that, add a little bit more, and we'll end up with about that much wire. Maybe we'll go a little bit more just for good measure. And again, wire is cheap, and it's a lot cheaper to only have to cut one length this long than having to cut 2 lengths this long. So that's that. I'll be doing the same thing on the other one, and then I'll be showing you guys how we'll be getting the various components mounted and start making some other wires.